All right, today we're talking about mole ratios, and we have to have a really good understanding of what a mole ratio is in order to do stoichiometry. If we look at our objectives, three objectives that we really have to understand. First, we need to be able to balance equations. This is just an extension of what we did in our previous unit in chemical reaction. So if I look at this, the first example, I've got two hydrogens over here, two chlorines, two hydrogens and two chlorines, in the reactants, and one hydrogen, one chlorine in the products. So I can just add, whoa, what happened there? A coefficient right there, and now my equation is balanced. Now I just look at my question, what is the mole ratio between hydrogen gas and chlorine gas? So now I'm going to use the coefficients in my balanced chemical equation, and that's going to tell me how many moles there are. And that's my second objective, is to be able to understand what the balanced chemical equation is telling me. It's like a recipe. It's telling me the relationship in terms of quantity between all the different components of my chemical reaction. So if I look at this first one, there's 1 mole of hydrogen and 1 mole of chlorine gas to make 2 moles of hydrochloric acid. So now a mole ratio just shows the relationship between two of those components, in this case hydrogen gas and chlorine gas. When I make my mole ratio, just like a conversion factor, 1 mole of H2, again that 1 comes from this one right here, to 1 mole of chlorine gas. So in this case, our mole ratio is between two reactants, hydrogen and chlorine. Let's take a look at our second example. We have iron plus chlorine gas yields iron 3 chloride. We'll first balance it. So I've got 3 chlorine here and 2 chlorine here, so I'll multiply those by each other. So put a 3 here, 2 here. Now I have 2 iron in the products. So I need 2 irons here. So I have 6 chlorines in the reactants, 6 chlorines in the product, 2 irons in the reactants, 2 irons in the product. All right, and this asks me the mole ratio for iron to iron 3 chloride. So here's iron. So I have 2 moles of iron, and I have 2 moles of iron 3 chloride. So again, that's a mole ratio, and that's the third objective for this essential question, is to understand how to make a mole ratio and what that mole ratio means. So again, in this chemical reaction, which is the synthesis of iron 3 chloride, 2 moles of iron would produce 2 moles of iron 3 chloride, and that's what my mole ratio says.